Yeah, that's something I'm pretty excited about as well. And I think that's one of my motivations. So that sort of brings me to my motivations for this. And, I can just start this presentation. So my motivation, first of all, is sort of learning how to communicate specialized ideas to people who come from different contexts and whose skill sets are different from me. Because I realize that's actually a big gap in a lot of teaching. And I struggle with that as well. So the hope is to get better at that. And I sort of want to see and understand how different people want to use the skills that we use in computer science. Sort of exposure to different problems helps me also understand how people use these skills. And I just honestly think that's quite fun. And finally, most of the people on this call are like friends or relatives. So I'm just pretty happy to be helping out everybody and, simultaneously seeing cool things happening. So those are my motivations. And yeah, so just a brief overview of what we'll do over the next few lectures is for every lecture, I want to start with a story that sort of motivates everything that we're going to do in that lecture. I'll give a short presentation after that. And I want to have like a flipped classroom presentation where each of you, like two people probably can do a 5-minute presentation on one topic, some very small topic that you can quickly Google and just, make a couple of slides about. The idea is not to, force you to study yourself, but the idea is just to get you to engage very honestly, because I realize this is out of a structured construct of like a university. So sometimes it becomes difficult to engage, and having some sort of like a submission or something like a, engagement device helps. Um, Finally, we'll end every lecture by building something because that's what computer science is for. We build stuff, so we'll build something. And we'll talk a little bit about, computational thinking. So what would be the steps involved in doing X? So all of you come with interesting motivations, with interesting problems you want to work on. And I think one of the biggest things about computer science that I took some time learning was how do we go about solving any new problem. And that's actually quite fun and interactive. So I think we'll all enjoy that. So that's the brief like anatomy of a lecture in some sense. And what will we learn in this course is also a closely related question. And my goal is to not teach you programming, but to teach you how to learn programming. The reason I say that is because I feel that most of the experienced programmers that I've met always, like, they never know the answer themselves, but they know how to find the answer. And that's sort of what differentiates computer science from a lot of other fields, is that things aren't very difficult. It's just that there's a lot of ways to get a lot of simple things done. And mostly you just want to Google it and see if someone's done it before. And there's something called Stack Overflow, which every computer engineer vouches for, and I'm going to vouch for that as well. We'll come to it in the second class. We'll talk a lot about that. In this class, I'll go over some more basics. We won't need to Google much. But the idea is to empower you to go and learn from where we stop, instead of, you stopping where we stop. So we will build some things together, and we will take sort of a sampling of things from data science, from building a website, from a couple of other, other important things that Python is used for. But I'll try to come up with an interesting application at the end of every lecture that we can work on. And then at the end, the goal is that we all build one thing that is for our own selves. And if you all stay motivated enough to finish this one thing, then we can all put it into our repository later on. And it will be like a nice showcase for everybody for what we did over the next 6 weeks, basically. So what I have in mind is that we'll have 6 lectures. And at the end of these 6 lectures, hopefully, you'll be able to go and make some small project that could be useful to you. And you could take a couple of weeks doing that maybe. And then we can maybe have like a presentation where all of us present what we made. That's the goal that I have in mind. Great. So this is the first lecture. And, the first lecture is always the hardest because you don't know what to start with. And there's a lot of assumptions about what people know, what people don't know, and a lot of jargon that I will struggle with. So that's the idea. So I looked up some popular courses on YouTube, first introduction to Python, first lecture in Python. And this one was very common. It seems what they like to do is they like to teach people how to store two values in variables and swap them. And I just could not understand the motivation for that at all. Like, why would you want to, learn how to swap two variables? So I went on to do something more interesting, hopefully. And we'll try to answer an urban legend today. There's actually a very interesting website called Spurious Correlations, which tries to identify interesting correlations that are obviously not true, but they make for interesting news articles. So this one, it talks about Nicolas Cage, and it talks about every year that Nicolas Cage appears in a movie, or the number of movies increase, the number of people drowning in a swimming pool actually increases. And this is a very high correlation. The two are closely aligned. Every year, Nicolas Cage does more movies, more people drown in a swimming pool. And this website is full of such correlations and such data. And what I was curious about was, if we can actually go and check this ourselves, that is this actually true? Can we find the data? Can we plot and can we find out what happens here? And the reason I picked this sort of funny example is because it closely relates to the assignment that I would give you at the end of this lecture, basically. And it all uses the same set of skills. So you can go and actually answer this question, or you can answer an allied question that I will give you. So let's start, and let's try to get you the skills to be able to answer this question of, how do two variables correlate and what goes on between them. So the first question that everybody would obviously be curious about is, what is computer science, what is coding, what is computer engineering, etc., etc. And I actually don't think it's a very good question to ask. I think a better question to ask is, let's try to relate this to our context and see what it can do for us. Let's think of computer science as a tool, and let's think of why it's such an empowering tool and where it draws its power from. Because by understanding what makes it a good powerful tool, we can actually learn to harness and think about computer science as, develop a sense of computational thinking and understand how to approach new problems using computer science. So essentially, what I like to think of computers as free labor. We have something which does work for us without us having to give it anything apart from electricity. And I write that down because increasingly there are concerns about how much electricity is being used by Google, etc., and how much energy they're using and how much heat they're releasing into the atmosphere. But presumably us working on our own laptops is not going to be that big a problem for the environment. And we can think of it as a free labor for us, as long as we know how to talk to the computer. As long as we can instruct the computer to do the right set of things, it can do our job for us. So we always need to think of it as free labor. And it's a special kind of labor where you have these very tiny little workers, but they're really not very intelligent. So they're hardworking, they'll get whatever you ask them to do. So if you ask them to add two numbers, they'll do it. If you ask them to subtract two numbers, they'll do it. They will never make an error there, almost never. And you can get them to do very simple things. So the idea is to break whatever you're going to do into very simple things and into very simple chunks, and to sort of come up with a set of instructions. When they're chained together, you're able to get something more important done. So you have these very simple steps, like you can store some information, you can give some information, you can read it. So for example, imagine writing to a file on your disk. You could, create a file, you can write stuff in it, you can read from it. So you can download a data set, you can create a data set, you can plot numbers in the data set, you can add, subtract, multiply, divide. And based on this, of course, you can do much more complicated mathematical operations as well. But honestly, pretty much every mathematical operation that you can think of for a computer is actually implemented as an addition at the base of it. Even subtraction, multiplication, division, pretty much everything. So essentially, this is a very big chunk of what we do, storing information, accessing it, displaying it in terms of, a plot or a graph or something, and just adding numbers together. Being very honest, most of what I do at the base of it is just this. We just have more complicated ways of, calling this, more complicated use cases. But essentially, if you know how to do this, you know the basics. And you can do a lot with just this much. And we'll do something fun today at the end of the lecture, so you'll figure out what I'm talking about. So think of computer programs just like, Lego blocks, and you can build some very fascinating things here. But as you see on the right, this is all made from Lego blocks. Each of those is like simple blocks like read, write information, add numbers, display numbers, things like that. And every piece of digital technology that you're using right now is relying on that. So every phone, every laptop has transistors inside it, which basically behave like, zeros or ones. I'll talk about that more in the second lecture. But that's all that we're basing all of this off of. And what allows us to use this flexibly in different settings for so many different use cases is really understanding how to chain them together. And chaining them together is what we call an algorithm in the words of computer science, pretty much. An algorithm is like a set of instructions. So the process of putting together Lego blocks to make and enable them to do something important is an algorithm. So for example, you could have an algorithm which sorts a list of numbers. You can have an algorithm which, given a bunch of data, tries to fit a line through it if you're doing data analysis. You could have something which tries to, get your, for example, Shruti mentioned that she has some users and she wants to understand how her users are using the product and things like that. You could understand how your users are behaving. All of this just using an algorithm, which is putting together simple pieces of Lego blocks. So the idea is that you want to split whatever task you have into subtasks, which are simpler and reusable for other jobs. The reason why I say reusable, one example for that is if I go back one slide, each of these Lego blocks is made of very similar looking towers. So if I know how to make, can you see my mouse pointer, everybody? I guess you can, right? So
yeah.
if you know how to build this structure, then this structure is not very far off. And if you know how to build this structure, then this structure is not very far off. So the idea of reusability is extremely important, and we'll talk more about that in the next lecture. But essentially, we use something called functions to define a reusable chunk of code which can be reused again and again. We won't get into that today, but we'll talk about that more in the next class. So in this class, what are we going to talk about? We're going to talk about the Lego blocks themselves. And then we'll talk about how to put them together for more interesting things in the next class. But specifically for the case of Python, Lego blocks are something called objects. So if you were to ask someone what is the building block of computer science, you'll get very different answers depending upon who you ask. If you ask an electrical engineer, they'd probably say something like transistors or a hardware device inside the computer. If you ask hardcore programmers, they'll say circuits which behave a certain way. Computer scientists would say, logic gates and things like that. But a Python programmer, the things that we're going to talk about today, we're just going to talk about something called objects. And objects, admittedly, is like a abstract construct. It's not a very easy to understand construct. So we'll give a lot of examples today and we'll try to understand what an object means. So suppose I told you that I have a pet dog or, a pet cat like Anna does. What are some questions you might be curious about that you might want to ask the dog? You, of course, want to know the name, the fur color, is it a male or a female? And of course, you care about actions like, can I play catch with this dog? Or can I feed this cat? And this set of attributes and actions pretty much defines an object. If you think about any other object, for example, I have this bottle of water in front of me here. That's an object. And what attributes does it have? How much water can it hold? What color is it? And what actions can I do? Can I drink water from it? So attributes and actions together pretty much define an object. And actions can also be called operations. That's slightly more traditional computer science lingo, but actions is what I would like to call them, just because, we don't want to get into the jargon. So let's try to look at some more abstract examples of what an object is in computer science. We can think of a lot of different kinds of objects. Imagine we have data which is geometric, an example, like a geometric structure. Then we can have a line object. And, of course, object attributes for it would be where does the line start and where does it end? And operations that I could want to do it, I would want to change the start point and the end point. If it's a data set of my employees, then I can have an object describing every employee. So I can have attributes like salaries and role in company, which defines the object. And I can do operations like task in the company, and I can change their salary. So I can assign them to a new task, or I can change their salary in the database. So these are just some examples of objects. And I realize that this is a little abstract. It's not very easy to grasp the first time you see this. So if anybody has any questions, I think this would be a good point to stop and take any questions so far. Great, no questions. I try to keep relatively longer awkward silences because I realize that actually helps people ask questions. But please ask if anybody has any questions, please ask. Because I realize it gets a little tricky as we move slightly more to abstract concepts. But the idea is that everything that you want to do in Python, you first want to define an object for it. And if I give you a new problem that I say, please take a look at this file and go through all the rows of this file and find me all the rows where, a certain value is present. This seems like a fairly easy job for a computer. Imagine this file could be a data set of, all the employees. I'm going to find out all the employees who earn more than, say, 10,000 rupees a month. The way to do it, to think about it computationally, would be to first think about, all right, I have a file. So I first need a file object. Then in that file object, I need to read. Then inside that file object, I have lines. So now I need a line object. What do I need in the line object? I need to read the columns. All right, what do I have in the column object? I have some numbers. So I need a number object. And what do I need to do with numbers? I need to compare them and say if they're greater or less than 10,000. Once you have this in your mind, this is basically the algorithm for the problem. And the Lego blocks that we're looking at for this problem are the file object, the line object, the column object, the number object, things like that. And that is exactly how Python code looks. If I was to like write down, which is exactly what we're going to go through in the second part of the lecture, which we have time for. Each of these objects will show up. And that's exactly how you think about writing a new program or a new script for a new job that you may have. You think about the objects and you think about how are they chained together. What are the different operations that I need from them? What are the different attributes that I need to design and decide for each of these objects? So yeah, and here are some examples of, snippets of Python code that I wrote in the morning. So this is not really code. This is what we call pseudocode, where we have the logic, but we don't really write it down exactly the way a computer understands it. So what I'm leaving out here is called syntax. Syntax basically means following a certain kind of structure that a computer can understand. When you write code, you want to make sure that a computer can understand what you're writing. And each language like Python or C or Java has its own syntax. So you need to write down instructions in a certain format. And when we don't follow that format, we just write down the logic. It's called writing pseudocode. And as a good exercise, I would suggest that whenever you try to think of a new problem, think of the pseudocode, because all the difficulty is actually in. So initially the difficulty is in syntax, because you look at simpler problems. But as you get better and you look at more complicated problems, syntax isn't really a problem anymore. The problem is pseudocode. What do I need to do to solve this problem? That's the more important thing to develop over the period the period of the class, I would say. So if we look at this example on the left, imagine I'm doing some operations here, and then I just want to measure how much time does it take to do these operations in between. So the way I would do that, I would measure time at the top, I would measure time at the end, and I would just subtract that, and that would obviously be the amount of time that was spent working on these lines or on these bits of code. So what I do here is I create a time one, which is object, and I save time into it. And I define time two, which is another object, and then I take their difference. So time one, time two are objects, and I basically need to be able to subtract them. So one of the operations that needs to be available for the time object is to subtract them, to get time differences between two different time objects. Similarly, on the right, if you see, employee one is one object, employee two is another object, and then I'm printing salary of first employee, salary of the second employee, and then I try to swap. I did actually do what all of the first lectures on YouTube do. I did swap the variables. So we assign the salary for employee two, which is stored here. So we take the employee first and we store it here. So what we're doing is that we take the salary of one employee and we store it in the second employee. But there's something here, right? This thing and this thing, it looks pretty complicated. What's going on? What's employee ID? What is employee? What is employee one? There's a lot of similar looking things in the sentence in one line of code. And that actually happens a lot. The reason is we'll just walk through one line to understand what's going on. This is what we call a class. A class is basically a set of settings which define what the object should have. So employee one is an object, and we understand what an object is. We understand that an object needs to have a certain set of operations, actions, and a set of attributes. So for example, for employee one, the attribute employee ID should be Spandan. And employee, this one with capital, is a class because that defines what the object should have. This is a little complicated and it's a little abstract, but it's something that becomes second nature once you start writing code. Essentially, objects are things which have some attributes and certain operations we can perform. For example, time one minus time two. Variables are just containers where we can store values. Statements are instructions given to the computer, and arguments are relevant information given in brackets. And the most confusing one, which is often slightly confusing as compared to object, is class. Classes help us create objects. So you can think of them as something which helps you create a new object. If you want to create two objects of the same kind, then you need to call a class. So employee one and employee two are both of the same kind. What does that mean? Is that they have the same set of attributes and they have the same set of operations you can do on them. So if you want to create them, you would call a class. Let's just look at this once again to understand. Employee 1 and 2 are objects of the same kind. And when I create them, I call on the class. And to specify specific attributes, when I call this class, I specify them in the bracket. So this line says, give me an object of the class employee with the attribute employee ID set to Spandan. And this one says, give me an object of the class employee with the employee ID attribute set to Ankit. This is a little confusing, I realize. So we can probably take a minute to look, or if anybody has any questions, we can ask right now.
The
Sure.
class is effectively, if I'm thinking about it in Excel, it's just a column.
You could think about it like that. Yes, you could think about it like that. It's a more abstract concept, but essentially, yeah, it groups together objects of the same type. Yes.
And how
does anyone have any questions? Sorry, yeah, go on.
And how does it know, like if you can have multiple classes, how would you know?
Right. So we never defined this class employee here because I didn't want to get to, I didn't want to write too much code here and confuse everybody. We'll get to it later on. But essentially, I just wanted to explain that somewhere in the backend, we've also defined the class. A lot of classes come predefined in Python. You can also define your own classes, but you don't want to look into that anytime soon. So right now, just don't worry about that. All that we need to know is we have Lego blocks, and Lego blocks are of different kinds. That's all. Great. Anybody has any questions, or is this all clear? Great. So we assume that everybody understands this, and we can just quickly do a recap once more because I think that this is something people get stuck on. We define an object of a certain class. When we're defining that class, we specify some arguments in the bracket, like employee ID in the previous case. And then we can have statements like print, and whatever we want to store, we can store it in a variable. That's the essential thing. And the important thing to understand is that the variable is also an object, because everything in Python is an object. That's just how everything is structured. So what can we store in variables? I mean, variables is something we've all seen in algebra, so it's a relatively easy concept to understand. But what are the different kinds of values you may want to store? Of course, you may want to store numbers. You can store things like names or employee IDs, which are both strings, which is that, they have characters, A, B, C, D, alphanumeric characters is what we call them. We can have different kinds of data, and we may want to store a list of them. What if we want to have store a list of all employees? For example, I want to store a list of all employees in my code, so that I can look up if I have an employee named Ankit or any employee named, Anna. So how do we actually store a list? Can we store a list? We can also store a list. So what we're looking at here is different kinds of data structures, which is different kinds of ways of storing data. And this is not exactly correct computer science jargon, but I'm going to stay away from it just to make sure that you all understand the concept of data structures. Data structures is just a structure that allows you to access and store data. Essentially, that's all that it is. And there are a lot of different inbuilt things that Python comes with, which you may want to use very often. For example, we store lists of numbers and lists of strings very often. So Python comes with an inbuilt class to create a new list. You don't need to write a class for it, which is what I just talked about here. So if you want to create a new object of a list, you don't need to specify the class for it. It comes by default stored in Python. So most of Python code comes from three ways. Either it is inbuilt, or you can load it using something called a module, which is code that someone else has written. Or three is you can write it yourself from scratch. Typically, you have to use all three of them simultaneously to get anything done. And we are not going to write our own classes, but we're going to write our own code, of course. So some popular data structures that we use very often is we use lists, which is 1, 2, 3, or list of strings. It could be a list of a list of names, and we have something called a dictionary, which is often you have like keys and values pairs. So you have pairs of data which are very important. For example, you may want to store a sort of a dictionary where you can look up a person's salary. So every data point there is defined by the person's key, which could be like their user ID, and the value is the salary. For any pairs of data that you may want to store, you can have a dictionary. This one we'll see a lot in the class, but essentially lists are pretty straightforward. Dictionary is something that if you have like a pair of data, you can quickly look up. That's the important thing. We'll go more into why people use dictionaries and why not some other data structure, but right now this is all that we need to know. So yeah, I'll just quickly go over. It's confusing but important that there are inbuilt data structures where we can create an object. Everything is an object. We don't need to write too much code for that. Dictionaries and lists are like inbuilt objects that we can very easily create. But at other times we may need to write our own classes to create objects. Great. So what if I don't want to work with information? Because I keep talking about information pretty much throughout this class. Sadly, everything that a computer sort of represents is information. If I look at this picture below, which is what I work with a lot in my own research, those are represented as what is on the right. So each pixel on the left is represented by a number, and the number represents the degree of whiteness or intensity, as we like to call it. So if you look at some of the most white regions inside this picture, they're represented by high numbers like 250 to 255. And if you look at the black regions, they're represented as zeros. Names of people, numbers, pretty much everything is represented as numbers. Even strings are represented as numbers for computers. So are audio signals and video signals and things like that. So pretty much everything does come down to numbers. That's how transistors work as well, which is something we're not going to go too much into. But it's good to know that everything is numbers at the end of the day. Everything is stored in the case of computers as binaries, as zeros, as ones. Why can you do that? Is because every number can be represented as zeros and ones. And what we work on is representing every kind of information as numbers. And we have to go through a lot of I would say, a lot of trouble to do that. But yeah, that's how computers work. That's basically why they're called computers, because they were made to sort of do computations on numbers, to add, subtract, simple operations in numbers. And then we realized that's actually quite powerful, that if we can do that, we can get a lot of jobs done if we can represent them as numerical algorithms. And that's what we do most of the times. Great. So the programmer's mindset, pretty much, that we've talked about so far, that we need to build over the course of this lecture series is we always need to think about what information do I need to use for the task at hand. How would I need to modify? What do I need to read? For example, if it's a set of employee records, then how do I store my employee records? What object will I need for each of these steps that I want to do? And what are the attributes and operations that I need to perform on these objects? And how will all of these objects interact with each other? This is hinting to the whole algorithm thing I talked about earlier, which is that if I have a file object, a line object, a number object, how do they interact with each other? This is pretty much the most important thing, I would say. If you have this sorted, then syntax comes easily, as in writing it in a format or just instructing it to the computer is not that hard. Great. So this brings us to the second part. I'm done with this lecture. We'll code now. But before I code, I'll just give everybody, a moment to ask any question, if anybody has any questions.
Spandan, I have a small question. I'm not sure if you will be discussing it, but I don't really follow. Why do we write print after the code? Like, is it calling an operation, or is it giving us the result or of something? Or
right.
Like this?
So printing is because we need to tell the computer to. So here's an example. We move forward. Imagine I just want to look up an employee salary, right? And the employee object is here. So something is stored in this variable. Employee1.salary is like a variable, and that's storing the employee one salary. Now I want to see it. So I ask Python to print this for me. And when I ask it to print it, what it does is it actually goes and sees what is the best available display that I have. And then it actually writes it there. So available display is usually your computer screen. So often, for example, if you're working on a server, like if you're not working on your own computer, but if you're working on a server that's lying somewhere else, and if you ask it to print something, if you want to print text, it can do that. But if you ask it to print an image, it'll just be like, I don't know, where do I print that? There is no screen attached to me because your screen is not attached to the server. So there's a lot going on when you type a command like print. There's a lot going on in the back end. For simple cases like when we're using our own computer, it's the sort of the computer interprets that as, let me display the value in front of the screen of the person. So that's what people sometimes call the console, which allows you to interact with the computer pretty much. So that's where displays come out. Does that answer the question?
Oh, yeah, it does answer, but I'm still kind of confused about it. Probably I'll read it and then get back to you later.
Sure. If you clarify further, I can try to answer again, I guess.
No worries. I think at the moment I'm good.
Cool. Anybody else has any questions?
Spandan, just one thing. So on this particular slide only, when we read employee 1 is equal to employee ID is equal to Spandan. So the employee ID is an attribute and a variable which is attributed to the object.
Right. So everything is an object. Employee ID is also an object at the base of it. If you look at things, if you actually look at how this calls code, you can look at something called the stack of code being called.
Okay.
Could you mute yourself, because I think I can hear myself. Yeah, sorry. So everything is an object. Employee ID is an object. And when you so what this does is that it assigns Spandan to the variable employee ID, which is also an object. This object gets sent to the class. It's called passed to the class, but you can just think of, you can think of this class as, something sitting waiting for information, like a box. And you write down Spandan on a piece of paper, which is an employee ID, and then you pass it inside the box. And this goes inside the class, which is a box, which is taken a piece of paper, and then it spits out an object, which is an employee object. So you can think of them in terms of, these boxes that you put information inside and they throw something out. That I think is slightly more intuitive to understand than classes and objects and things like that. But the important thing to understand that is the way Python is structured is each of these in itself is an object as well. Does that make sense?
Yeah, it does. Thank you.
Great. So yeah, does anybody else have any questions? Great. So we can move to the coding part of the class, I guess. Yeah, so this is something I suggest you all can use for coding. This is something called Colab. It's by Google. It allows us to, it's basically just a computer running on Google servers. And you can just write down Python commands here and you can run them. You don't need to spend any time setting up Python on your computer. You don't need to set up anything on GitHub. You don't need to set up anything on, Azure is something that people often use in their classes. I think for the time being, for the beginning, don't worry about anything. Just try to write some code and just try to familiarize yourself with, things like x equals 1, print x, len, things like these. So to do this, to access this for yourself, all you need to do is go to this website, colab.research.google.com, and it'll ask you to log in with your Google account. And you can log in with your Google account and you can create a new notebook and you can write down stuff there. So I'll walk you through this pet sort of application that comes almost inbuilt. So the way Google Colab works is that it also allows you to upload and download files. And it actually comes with some files already lying there. So just to make it easy for you to not have any setup work, I'm actually going to use the same file that it comes with. I think it's just easiest to understand the rest of the code first. So, recap, everything is an object and variables. So variables are also objects. So here I just set x equals 1 and I set y equals 2. And then I can just say z equals x plus 3. So what I've done here is that I have instantiated, is the word that we call, we've declared or instantiated. We've declared a variable x equals 1, and we've declared a variable y equals 2, and then we've declared a variable z, and we've set it equal to the sum of x plus y. And this is, just the very basic, but it's important to go over it, I think. And then we can, if we want, we can add a new code cell by clicking here, and then you can just say print z. And this is going to spit out 3, hopefully, right? So what are X, Y, and Z here? They're all variables. And we can, of course, do much more interesting things with variables than just assigning them to ones and twos. So what we're going to do is we're going to read some content from a file. So let's look at the anatomy of this line, because it's a little confusing, I think. So we first of all say we want to open this file. So this file tells us where it is lying on the disk of the server, and it's right here inside content, inside sample data. Inside that, there is this file here. That's what we're loading. This one says that I want to open this file for reading, not for writing. Why do we do that? Because people, if you open a file for writing, you can overwrite what you're writing on and things like that. So it's just a fail check mechanism which doesn't allow you to write onto a file unless you unless you know you want to overwrite a file. So R here is just saying I want to open it for read. If it had W there, it would be for opening for writing. And it says with open this thing as F. This is just a fancy way of saying that open this file and store it in the object F. And then I will use the action read lines, the method or the action or the operation read lines, which is, it just reads the lines, and I'm going to store that in content. So what we did here is that we opened a file as an object, asked it to read lines, and then stored that in a variable content. So we can see this whole object, attribute, variable thing all over again and over again. So what is F here? It's a file object. If you look up online, it's called a file handler. It's just an object. It's just easier for our case to just think of it as an object. So everything is an object. It is an object here as well. When a file is opened, when an opened file is created, it is supposed to be also an object. And of course, we want to read lines from it, which is an inbuilt function that comes, and then we use it to read lines. Content is the variable that stored it. And then here's an example of an interesting attribute, an interesting method or a function or an operation that comes inbuilt with Python. So pretty much for every object, you can just call a len on it, and it gives you the length of it. This actually works pretty much for most objects you will come across, and it's a very important one to know. So you call len, it tells you how long this line is. I haven't done this line. Right. So it says there are 3,000 lines in this. Now, content is a list of lines, because when I read this file had 3,000 lines in it. It got stored in an object, which is a list, because f.readLines actually returns a list of lines. So content is a list object. And for a list, I can actually go inside and see its different lines. So in Python, everything starts with a 0, not with a 1. So the first line is going to be accessed by putting these brackets around it, square brackets, and then you can just mention the line number you want to see. So to see the first line, you can say content 0. To see the second line, you can say content 1. And to see the last line, you can say content -2. To see the second from the last, you can say -2. So basically, positive numbers start from the left and negative numbers start from the right. But that's basically a way to look at a list object. If you have a new list object and you want to see what's going on inside it, you can access the values inside that list. In terminology, this is called indexing a list, to be able to index and see what's happening inside it, but you can just think of it as accessing. Right, we have a question, yeah.
So just the very simple question. So like the length of content, that's the number of houses here, or that's just the number of...
It's a number of data points here. So in this case, the first line actually gives us the column headers of the data set. It says it has longitude, latitude, housing median age, things like that. This is just a data set of houses that comes pre-built, inbuilt into this data set. And each of these defines, I think, a house. So this is an example of a data set. You could have houses, you can have employees, you can have different kinds of data sets here. And this is how you would access the data sets. And it comes with another really nice inbuilt function that's helpful, which is to split it. So if I was to run split on the first line, it would split them on each of these. And I get this out. So what I've done is that I've taken one element of the list, which is the first row, and I've split that into a list in itself. Which does that make sense, or is that a little confusing?
Spandan, why are you using different brackets over here? Like, do they denote different things?
Yeah, so the different brackets are very important in Python. and they all have like a different use case. So we will typically see 3 brackets come up very often. We see this one, which is called the parenthesis or the normal bracket. We see the square bracket, and we see this one very often, which is, a curly bracket. When we talk about dictionaries, this one shows up. We won't talk about dictionaries in this piece of code, so we won't see them. But yeah, the kind of bracket you use is actually very important. I don't think there's a very standard reason for what gets used for what. I think I've just memorized by now what bracket comes where, but it takes a little bit of time to understand which bracket to use when. Right. So we just called an operation split.
Spandan, one question.
Sure, go on.
Could you just scroll up a bit? Yeah. So how does Python differentiate between the 2 contents that I see here? So when you say with open/content/sample, and then you again create another object which is called content. So how does it differentiate?
So I don't set a new object here. I only have one object which was set. If you create a new object, there's always going to be an equal to sign, because you need to assign something to that object. So here I assign 1 to this object, 2 to this object, x plus y to this object, f.readlines to this object. So unless there's an equal to sign, there's no new objects being created. What I'm doing here is I'm basically just asking for some information inside it. So it doesn't create a new object. It just goes and gives me the information. You're right that this also is in its own right an object, but we haven't created that. That's just how, that is stuff that Python takes care for us, under the hood. We don't need to worry about that right now. That's one of the reasons why Python is so easy to work with, because it just takes care of a lot of things by its own self that you don't need to worry about. So in fact, if I was to talk about a slightly more complicated language like C, they don't have lists like this. There's no arrays. You have to define each of these separately and then assign them. It's very complicated. Python is not that complicated. So yes, this is its own object, but we don't need to define it. If we define this list object, each of the members of the list automatically get defined without us worrying about it. Does that answer the question?
Yes, it does.
Great. So
sorry, quick question. So like there seems to be 2 ways to use, there seems to be 2 ways in which we can make actions in Python. One is like the example above where, like we said, with with open and then the brackets as f, and then the second appears to be the dot operator, so f dot read lines.
Yeah.
What's the difference between the 2?
Right. So there's actually more than that ways to do it. There's a lot of different ways to call operations. There's multiple things going on here. This is, when I do a dot, it's typically an inbuilt operation that comes with the class. So when I create f, the object here, it's of the file handler class, and that class specifies that you need to come with the read lines function. So for example,
what lets Python know that f is of the file handler class?
This.
Okay. So with automatically creates a class file handler only.
Yes. So whenever I do an open some file with R or W, it knows that I'm opening a file. So it creates f with the file handler as a file handler class, and then that comes with inbuilt functions like read lines and write lines, amongst most important ones. And see, open is something that it's just inbuilt in Python. It's not a function that we have defined. It just makes things easier, because otherwise we have to define everything from ourselves. It becomes very difficult to code in that language.
Got it.
Right. So it helps us out a lot automatically, and that's something nice. Though it still seems, I'm sure this seems like alien language right now, and it's very confusing right now. But you get used to these things if you do them once or twice.
Why can't we just write f is equal to read lines?
You can do that.
Why isn't f equal to f dot read lines and the name of the file in there?
You can actually do that as well. People just prefer this because for reasons I'm not going to get into, it just prevents certain kinds of errors. That's the only reason why the with syntax is preferred. But yes, you can completely do the f equals thing as well.
Okay, got it.
Yeah,
thank you.
It just prevents certain errors. But yeah, so it's also, there are certain biases that my coding patterns also show up here. So that's another reason why you see it like that.
Got it.
Right. So yeah, so this dot split, as Shruti just mentioned, is another, operation that came inbuilt with this list, with this string actually. So content is a list, but each of the elements inside that list, for example, each of the rows in the data set gets stored as a string. So this is a string. And the way you know it's a string is because it's surrounded in this colon, this apostrophe. So single quotes or double quotes show that it's a string. If this was just a number, it would show up like this without strings. So this is stored as a string, and strings have an inbuilt function called split that you can call, and that allows you to split the string along a certain sort of parameter that you want to split on. But yeah, so can we make a node lists? Of course we can. We can make, list one, we can assign it to just this list 1, 2, 3, 4. If I was to go here and I just do a print, if I just do a print list one, it shows up like this. It's a list. I could create a list of text of text like this. I could do list 2 equals hello 2. And the way Python knows that this is a list of strings is because I've specified that each of these is a string and not a number. Here I didn't put them. So if I want to do this, I could also do if I store it like this, then these things get stored as strings, not as numbers. So I can't add them anymore. If I do this plus this, it's going to give me an error. But if I do this plus this, it's just going to return 3, which makes sense because when you specify it like this, Python knows this is a number. I need to allow operations like addition, subtraction. When you write it like this, it tries to associate to it things like you would associate to strings. So for example, if I was to do something like z equals 1, 2, 3, 4, and then I do one of the most popular things you could do with a string is split. So if I do this, it's going to give me, it's going to split this. Oh, it didn't split it. This is unexpected behavior for me as well. I would expect this to split, but if I do this, it'll split for sure. And I could specify where it can split by doing things like this. So this is just stuff that you would want to do very often with strings. And I know it's a lot of, split and content and read as f things going on. But if you read over this 2 or 3 times, it will become very easy to understand what's going on here. Right. So this code that I have here, it's a bit of a chunk of code that's a little complicated. But what I'm doing here is I'm just reading all the columns in this data set. So I've stored all the columns or a certain column in this variable, and I've stored all the populations here in this variable. And once I have this, I've stored these lists. I call on something which is a module. As I mentioned before, modules are chunks of code that are written by people that are very often used. So you don't need to write it from scratch. For example, to get the mean of a list of numbers, you can use something called NumPy, and you can just use this to get the mean of the numbers. I'll walk over this step by step, so don't worry about this. But essentially what I'm showing is that I can store these numbers inside the file as a list, and I can do operations on that list, like getting its mean. I could also do things like plotting it. And I could also do things like plotting 2 of them together to see how they look like. So for example, one very important use case that we can all think of right now is if you want to compare how COVID is growing in 2 different regions in the country, you could presumably think of a file or 2 files which has numbers updated daily. You could load it in and you can plot it. And that's something that, for example, I was doing myself when I was playing with the COVID numbers. There are these files that are given by Johns Hopkins University, and you use this thing to plot them to see how they look. So let's just quickly go over this one by one, because I want you to understand the steps here. I think the bigger picture is sort of clear. What I do here is something called a loop. So we've seen quite a lot of things. I'll just quickly recap a few of them. We saw reading from a file. This is how you read from a file. We saw storing it into a list. We saw how do you take the contents of that list and do something to it. We could split it, we could look at it, things like that. And now we want to go over each of them one by one. So of course, one of the things you would want to do very often is you would want to take a list of numbers and you would want to do the same thing to them, or you would want to apply some kind of operation to them. So one reason for one very normal use case could be, let's quickly go through all of the housing median ages and then just see how many of them are greater than, 40 or 50. And if you want to do that, the way to do it is that you store everything in a list. So that's one object. And then you go over each of them, and the object that you get at every position in the list is a number. And then you just see if the number is greater or less than each of them. But greater or less than any number that you care about. For example, in this case, you could go over the list which stores all the values, and then you can check if it is greater than 20, if it's greater than 30, things like that. But to do this, you need to sort of go over each element in the list. And the way to do that in Python is called loops. Loops are just a way to repeat a chunk of code over and over again. So for example, if I do something like for I in range 10, print I. This is a for loop, which basically goes through here, and it starts with I equals 0. It prints I, it goes over again. This time I has been increased by 1, so it's become 1, and it keeps going over it like this. And this is just a loop that you see very often. Why would you want to do this? One very simple example is looping through all the lines in a file. Is this for loop clear to everybody? Because it's a little, it's new, I guess. I'm not sure if it's new for everybody, but it might be. Great. So I think it's fairly intuitive what a for loop is doing. There are different kinds of loops. The most important one that you would use most often is the for loop. And the important thing here is that, when you say for I in range 10, it goes from 0 to 9. Why does it do that? Python always starts from 0, as I told you before. This might seem awkward, but it becomes second nature. For example, for me, I actually start coding, like I start with 0 now every time whenever I do something. So it just becomes second nature over time. And this is the loop that you can utilize. We're using the same thing here. So here what we're doing is that we're looping from 1 to the length of content. So why didn't I just write 3001 here? Because we just saw length of content is 3001. I could just replace this with 3001 and it will work. But the reason is that you want to write code that can be reused very easily. So what if I want to run this whole thing on a new file here? Then when I load a new file, this will change and all of my code below will break. So I'll have to rewrite that. By assigning all of this to content and storing using this len content instead of writing the number myself, it's just easier to make sure that the code works if I make changes upstream or downstream. So such code is just, it's more flexible, it's slightly easier, and you also don't need to print this out. You can just write it and it automatically gets done without worrying about the numbers. So what I do here is I loop from 1 to the length of that variable. So it goes from 1 to 3000. Each of them I store, I read as I did before. I store that line into C. I strip that, that's just some basic operations. I split it again into parts. So now what I do is that if I was to print, let me just print parts here. So this is, splitting the last line because it went in the last line. This is splitting the last line into these values, and these are the values in the columns. So for each of these values, for each of these parts, I read the value in the second column. So when I say 2, it's 0, 1, 2. So the third column, I read the value in the third column, and I just add that to this list. So append is a way of adding things to a list. You could, when you start a new list, you could just say list 4 equals 1, 2, 3. But another way to do this same thing would be to first define an empty list where you don't give it any values. Then you go from for I in range, we want to start from 1, and then we want to go to 4 because it stops 1 before. So I would just say for list I would just say list 4 dot append I. And if I was to print this, it will give me, oops. it gives me the same thing. So I could do it like this, or I could do it like this. The reason why you may want to do this is because you loop over the contents in an existing list like this, and then you do some operation to them and you store them to a new list. One reason could be, you want to get the list of all employees that earn greater than a certain amount of money. So you loop over their records, you see how much they earn, you compare it to a certain value, and then if they match the condition, then you can store it inside this. Great. I do the same thing for population. The only thing I've changed here is that I've changed the column number, and I call this module. Inside the module, there is this inbuilt function called mean. I use that to get the mean, and then I use this another module to plot. So plt.plot here is just asking it to plot, and np.mean is just asking for the mean. So these are just inbuilt functions, not inbuilt because we're calling these modules, so they're not inbuilt. We're using these modules, but that's essentially what we're trying to do. So this is a working example of how you would read a new file. You would go through its contents. You would check what's going on. You could save things. You could print things. You could display things. And I think this is like a very neat inbuilt example, like a neat sort of like an application that is actually quite important because we do this all the time. And if anybody wants to make use of this for their work, I think this in itself is a standalone application. So I think this is where I'll stop the code for today because I realize this is a lot. So if anybody has any questions on this, we can go over that right now. And then we'll try to wrap.
That's a very small, tiny question I've been wondering
Sure.
about. So, is that then a good practice that if you have a list of strings to do the split function in that?
Is it a good practice to split a list?
Yeah, because I'm just wondering why exactly do we do the splitting? Do we have to? Like, does Python not recognize it as different values?
So the reason is that when you ask it to read the lines, it just reads the lines. Because different formats use different things. For example, here it is separated by commas, the data. You may have a data set where things are separated by spaces, for example. There could something else be, there could be something.
Separation.
Yeah. So as I said, you have tiny workers that are very dumb. So, they don't do too much for you unless you ask them to. So you ask it to read lines, it reads lines. That's it. But it gives you the power to do everything yourself along with that. So the idea is, just keeping things transparent, and you typically have like a small step for everything you want to do, as opposed to, I would say most of the programs like Excel and stuff that people are used to tend to package all of this into a button, and that's great if it matches your use case, but it's not flexible. So if you want to use something which is like, if it doesn't match the Excel format, for example, then you have a hard time and things like that. The whole idea here is to sort of empower you to do things, small things, which can be chained together to do good things and important things. And yeah. Great. Any other questions? Cool. So if you have any other questions, you can always ask me, later on. But yeah, so what we just did is exactly what we need to do to actually recreate this graph, which is what I talked about earlier, is that you can actually check all the years where Nicolas Cage had higher number of movies. You can plot this, and you can plot this, and you can see if there is actually a correlation between people drowning into a pool and Nicolas Cage movies coming out. In general, I highly suggest checking out this page, Spurious Correlations, just for fun. That's where I just got this idea from. But yeah, that's basically all that I have for you today. And one assignment that I want to give to you, which only uses exactly what we have here, is that you could actually use the tools today to plot COVID-19 growth in different countries. And I'm going to make a text file which matches the same format, so it'll work, and I'll load it there. So you wouldn't need to change anything here apart from, the file names maybe, or just probably very few small changes. But I'm pretty sure that everything that is here is enough to plot a graph of how COVID is growing in different countries. If you want to do some other application, that's also perfectly fine. But essentially what I want you to get comfortable with is opening an account in Colab, going and printing some things, reading a file, looking at the rows of the file, finding relevant information in the file, and plotting something. Because I think that in itself is like a very neat and very important application that could be quite helpful. But yeah, that's basically what we have today. And if you're done with this assignment, in computer science speak, you would know how to import modules. You would know how classes and objects and lists and file handlers and IO and plotting and a lot of other things work. So you're learning some very cool sounding things, at least to the nerdy people, but you'll actually be doing some very simple things that we saw here. So that's basically all that I have for today.
Are you going to share slides?
Great. Thanks so much, Spandan.
Yeah. Also, just a quick word to practice your code, Colab. Where's everything stored? It's all stored in this link. I've sent this to you before, I believe. I'll add the lecture, and I'll add this lecture, and I'll add the data set for here. You don't need to install anything. I'll also tone down the number of emails you guys get, because it's just easier to sort of work off of GitHub. So I'll just put things on GitHub. And one very important thing is that, of course, you'll have some questions. And if you have a question, what you do is that, first of all, you need to go to GitHub and make an account. That's pretty straightforward. You wouldn't need to do anything for it apart from standard account making things. And you go to this link, you go to this, what we call a repository of code, and you go to the issues. And then you create a new issue. So if you have a question and you just say, I didn't understand slide 18. Okay. You can just add more information here and you can submit the issue. And anybody who wants to help can help. If anybody has anything to add, they can add here, and I can try to answer if there's any question here. But in general, it's just nicer to have all the questions here, because it becomes a nice question bank for anybody who wants to, go through all of this stuff later on. Great. That's basically all that I have for today. But yeah, hopefully I'll see you all next weekend.
Spandan, one thing, will you be uploading the presentation somewhere?
Yeah, I'll upload the presentation and the lecture both on GitHub, and I'll upload the video lecture which I'm recording right now on YouTube, and I'll add the link there as well.
Okay, great. Thank you so much, Spandan.
Yeah, of course. Hope this helped.
Bye.
See you next week.
Very much.
Bye-bye. Bye-bye.